So now we've seen that rhombuses are really useful for doing constructions. Now we will construct perpendicular lines and also the perpendicular bisector of a segment using rhombuses. So first, imagine you have a line, AB, and you want to construct a line that's perpendicular to the given line through some point P. So let me give myself a point. I'll call it P. In order, so what we all like to do is to just kind of sketch in. Oh, looks like it's perpendicular, so that's about correct. But we don't want to just use. We don't want to just eyeball it. We want to do an actual construction. So the thought is let P be the vertex of a rhombus, and AB be the diagonal of your rhombus. So I need to find the other vertices. So what I'm going to do is set my compass to some length. We just can't make it too short. I want the compass, I want the arc that I draw to intersect my given line in 2 points. So I'll set my compass to a specific length and I'll let it intersect my line in 1 point and also in another point, because I need 2 intersection points. That gives me 2 more vertices of the rhombus. You can call one of the points A and the other B if you like. And now that gives me 1, 2, 3 vertices of my rhombus. The next vertex has to be down here somewhere, and it has to be the same length. So I'll keep that length, set my compass at the first intersection, draw an arc, set my compass at the other intersection point, the other vertex, and draw an arc. And now I have the last vertex of my rhombus, which you could call Q. Doesn't matter. So now if I connect P to Q, then that will give me the other diagonal of the rhombus that I was constructing. And now I'm guaranteed to have perpendicular lines. So I've just constructed a line that's perpendicular to AB through the point P. And let me highlight for you the rhombus that we constructed, that we used for this. We found this distance and this distance to be the same using our compass. And then using that same distance, we found a point Q. So I have 1, 2, 3, 4 equal sides. And the diagonals of this rhombus are perpendicular. Actually, they're perpendicular bisectors of each other. All right, you can also use rhombuses to construct the perpendicular bisector of a segment. This is something that we did back in section 12.2, but now we're just going to make sure we understand that we're using properties of rhombuses. Last time I think we decided we were looking at isosceles triangles. So what I'll do is imagine that the segment AB is one of the diagonals of my rhombus. So what I want to do is take my compass and set it so that it is more than half of the distance from A to B. And I'll draw an arc from the point B, and also come over and draw an arc from the end point A. So then if A and B are 2 points, 2 vertices of my rhombus, now I've just created C and D down here. And if you connect C and D, what you get is a line that's perpendicular to AB that bisects the line. It chops it into 2 equal sized pieces. And I'd like to highlight that rhombus that we just created again. Remember, we set our compass and we kept that same length so that the distance from A to C is the same as the distance from A to D, which is the same as the distance from B to C, and B to D. So there's the rhombus that we kind of constructed. So all of these lengths have got to be the same, which tells me that I know that these two diagonals are perpendicular to each other, and also that this line that I drew bisects that segment AB. So rhombuses are great. They have wonderful properties. Let's now use these ideas to construct altitudes for each one of these triangles below. So what is an altitude? It is a line segment or array emanating from a vertex. So for us, it'll be the vertex A that intersects the opposite side, or in this case, you'll see it intersects the line containing the opposite side and intersects it in a right angle. So the way that we do that is we use a construction for a perpendicular line to a given line through a given point. So I want you to imagine here that the line that I'm given is the line containing the base. So this is my line. You can call it L if you like. And the point that I'm given here is the vertex that I'm trying to construct the altitude for. And again, imagine that you just drop the line straight down so that it intersects the opposite side in a 90-degree angle. So let's take a look at what we did last time. This was the rhombus method for constructing a line perpendicular through a point. So we just imagine that this is one vertex of the rhombus and we construct the other vertices. So I imagine that A is the first vertex in my rhombus. So then I'll set my compass to any length really, and I'll let it intersect that line twice. Oh, interesting. It intersected at C. I didn't do that on purpose. So I've got 2 points of intersection. Let me keep that same length. So now I have 1, 2, 3 vertices of my rhombus. And I'll draw in an arc from C and move over to my other intersection point. I needed to do a little bit more than that. And I'll draw an arc from this other intersection point. And this gives me the last vertex. So now I can go ahead and connect the vertex A to this new intersection point that I made. And that gives me the altitude. And I can highlight for you, this is the rhombus that I made. And here is the altitude. So this is the altitude of the triangle that I was given. All right, now over here, the difference between the example we just did and the one we're about to do is that this triangle, the first triangle I was given, this was an acute triangle. So the altitude actually does lie on the interior of the triangle. This one is an obtuse triangle. So the altitude is going to look kind of funny. We're going to have to extend the side BC so that the line coming off of vertex A here can actually intersect in a 90-degree angle. So it's going to look strange because the altitude is going to be outside of the triangle. Let me just highlight our triangle so we don't lose track of what we're doing. All right, so step 1 for constructing perpendicular lines was to imagine that the vertex A is the first vertex in a rhombus. I'll set my compass point at A, and I will make an arc to indicate the same distance from A to that intersection point, and the same distance over here as well. Use that same, don't move the compass arms at all. Position the compass point at that intersection that you just made and draw an arc. Move the compass point over to this vertex of the rhombus and make an arc. That will give you the last vertex in the rhombus. So now I can go ahead and drop the diagonal from A down to this opposite vertex I just made. This time I'm going to stop at the line. There's the altitude. So again, let me just highlight, you don't need to do this part, but I just want us to understand that we are constructing a rhombus here by letting A be one vertex, and then I construct the other three vertices of the rhombus. So these sides are all the same length. All right, our last example, let's construct the altitude from vertex A for this triangle. So I had an acute triangle, an obtuse triangle, and over here I have a right triangle. It turns out that in a right triangle, if I drop a line segment down from vertex A down to the side BC so that it meets in a 90-degree angle, well, that's actually that's already the one side of my triangle. So this is the altitude. There's no need to construct anything here. Side AB is the altitude.